Hello everyone, welcome to Diksha Karnataka YouTube channel. So in the PU1 series, today I am going to discuss another important chapter, that is motion in a plane. It is a huge important chapter in terms of concepts and a lot of things that we are going to learn in this chapter for the first time as well. So before I continue, just let me tell you what are all the things that you are going to learn so that you get a clarity. So scalars and vectors, their difference. Okay, we have basic idea about scalars and vectors, but this chapter we will be understanding how to denote a vector, how to add two vectors, etc. So multiplying vector by a real number, addition of vectors, graphical method, resolution of vectors and unit vectors, vector addition, analytical method. We will also learn position, velocity and acceleration in 2 dimension. We have already learned about it in 1 dimension. Now we will see what to do in 2 dimension as well. Motion with constant acceleration, projectile motion, the path is parabola, uniform circular motion, summary of the and some workout examples. Some examples we will solve in our session today as well. So this is the main core of today's session. And first of all, if you have not yet subscribed to our channel, so don't forget to subscribe to our channel, because each and every chapter of your PU1 and PU2 we are covering in our channel, and we will try to help you as much as possible. And if you have any doubts, any questions, feel free to ask me in the comment section below. I will try to address them as much as possible. So without any delay, let's start with the first thing, that is the difference between scalars and vectors. So what is a scalar? Scalar is a quantity which has only values. Now values are called magnitude. Magnitude means the value only. Okay, completely specified by a single number with a unit, combined by the rules of ordinary algebra. Ordinary algebra means 2 plus 2 equals to 4. So if 2 plus 2 equals to 4, then it is a scalar quantity. Okay, in vector also some cases 2 plus 2 is 4 is possible, but if always 2 plus 2 is 4, then it's a scalar quantity. Okay, example: distance, speed, mass, temperature, time, density, etc. They are example of scalar quantity. Okay, now vector. What is a vector? Vector actually means that it has a direction. Vector means a direction. So magnitude and direction. So it has a value as well as a direction. It obeys the triangle or parallelogram law of vector addition. So basically we call it the method of vector addition. So in vectors, 2 plus 2 may not be 4. Okay, many times it will not be 4. Only in some specific case it can be 4. Sometimes it can be 0 as well. So 2 plus 2 is not equals to 4 in vector addition in general. Okay, written with the bold or with an arrow. Okay, so in many cases in printed letter you might see that the letter is written in a bold format. So for example, if you see that bold, so this is a bold letter, okay, then you see that this is a vector quantity. And many cases while writing in your exam, you cannot differentiate between bold and light numbers. So you have to write, whenever you are writing in the exam, you will write a vector as this. Okay, it will always be mentioned like this. Okay, in textbook you might find something which is written like this, okay, which is clearly bold than the other A. So you can differentiate, okay, this is a bold A, this is a non-bold A. So that's how you differentiate. But in our life we will use a vector sign. Okay, so example are velocity, acceleration, force, displacement. Distance is a scalar. Okay, displacement is a vector quantity. Okay, so displacement is a vector quantity, whereas distance is a scalar quantity. Okay, two vectors are equal only if they have same magnitude and same direction. Okay, so two vectors, they will be called equal vectors if they have same magnitude as well as same direction. If one of them, say both of them are equal but they do not have the same direction, we will not call them equal vectors. So equal vectors means same magnitude, same direction, same equal scalar. quantity can be same. Obviously direction is not there, right? 2 kilograms you are measuring in Bangalore or 2 kilograms you are measuring say in London, does not make any difference, right? So both places it is same. But if I say 2 kilometers to the west and 2 kilometers to the south, they are different even if you are standing at the same position, because their direction are different, right? So two vectors can be different. Now let us understand another thing, position and displacement vector. So position vector, what is a position vector? Position vector is basically denoted by the coordinate system. Okay, position vector is basically denoted by coordinate system. So we need to use our x and y coordinates. Just let me draw the say this is just a second. This is my x-axis and y-axis. Now we know that in coordinate geometry, if I want to locate a point say P, what do? We measure the distance from x-axis, we measure the distance from y-axis, and we call x comma y. That's how we denote any point in coordinate system, right? Now in vector notation, this point is not a single point, it is a position vector. It is a position vector. So what is the meaning of position vector? You join this point starting from origin. If you join this point, okay, just give me a second. If you starting from the origin, if you join this point, then it is called position vector. This is called position vector. This is position vector. Now how do we denote this position vector? So suppose this point is O, starting point is origin O, ending point is P, then OP is my position vector. Okay, OP is my position vector. Generally it is also denoted as R vector. R is basically the universal symbol for position vector. Okay, and how do we write it? We write it as x I cap plus y j cap. Now what is I cap and j cap and k cap, we will see. Just give me a while. So this is how we generally denote a position vector. I will explain what is I cap and j cap. Basically it is x and y. So this x coordinate and y coordinate is taken, we multiplied with two vectors, I cap and j cap. I will explain what are these just a second. Okay, now if suppose we have 2 points P and P dash, okay, one is say x comma y, another was x dash y dash. Okay, those two are two different points. So when you take their position vectors, they will be different. One is denoted by R, another one is denoted by R dash. So if you are trying to find the distance between these 2 points, there is a way to do that in vector geometry, which is basically the subtraction of vectors. It's a vector. So just to double check, I am adding vector sign as well. So displacement is a vector quantity. So displacement is a vector quantity. So this delta R is a vector quantity. All of them are actually vector quantity. Okay, it depends only on the end points, never on the actual path taken between them. So displacement depends on starting point and ending point. How you go there, independent. Displacement is always a straight line path. It's the shortest path between 2 points. Displacement is the shortest path between 2 points, that is called displacement. Now displacement is always less than equals to path length. Okay, so if suppose you are traveling from A to B, okay, if you are traveling from, just give me a moment, you are traveling from say A to B, you can go by this path, you can go by this path, you can take any other random path to reach, right? So this is all these are the path length. So this is say path length P1, P2, P3, P4. So these are all path lengths. Now as you can see, only along this, if you are going from A to B, then only the path length is exactly equals to the displacement. Okay, so displacement is always less than equals to path length. Path length can sometimes be called distance traveled. Right, so path length can sometimes be called distance traveled. So if you take these 2 points A and B, if you join these 2 points, that is the shortest distance, which is displacement. Okay, and any other path you take, displacement will always be fixed no matter what path you choose, right? So displacement is always a vector quantity, it is a fixed quantity, no matter what path you choose. Suppose you want to reach from A to B, you can go like this also, A to B. Okay, so this is your total path, but displacement will be only this. This is the displacement. Okay, so remember this. Next is okay. Before going into that, let me come back and tell you what is this I cap and j cap vectors are. So I cap and j cap vectors are called unit vectors. They are called unit vectors. Okay, what is a unit vector? Unit vector refers to a vector having magnitude only 1. Unit vector, we will discuss a little bit more about unit vector, but before it is coming over here, let me explain. Unit vector magnitude is 1. This is fixed. Okay, unit, that's why it is called unit. 1 unit, for example 1 kg, 1 meter, right? So these are all units, meter, kg, centimeter, they are all units. So when I say 1 unit length, generally we refer 1 meter length, right? So here also, as we say 1 unit vector, that means its magnitude is 1. Now direction wise, it can have 3 different directions. Direction wise, it can have 3 different directions. Okay, one is along the x-axis, along the y-axis, and along z-axis. So even though this chapter is a 2-dimensional chapter, we need to know a little bit more about 3 dimension, because if you take any 2 axes, it still becomes your 2 dimension, right? If you take x and z axis, xz plane, that is also a 2-dimensional plane. Xy plane, our common friendly plane. YZ plane is also a 2-dimensional plane. So you need to know unit vectors along all 3 axes. Okay, suppose z axis is x comma y, z is here, so this is the z axis out of the page. Okay, what is the unit vector? Generally, unit vector along x direction is denoted by I cap, unit vector along y axis is denoted by j cap, and unit vector along z axis is denoted by k cap. Okay, I, j and k, these 3 are the 3 unit vectors. Okay, so I cap and cap, this sign cap or hat, this refers to unit vector. For normal vector we use arrow, for unit vector we use cap. Okay, so I cap or I hat is unit vector along x axis. Okay, it is along the positive x-axis, it is positive. If you go negative x-axis, it will be minus I cap. So if you see, in some cases you will see some of the values are minus. Don't be afraid. Minus means the axis is opposite. Okay, suppose you have a point x comma minus y. Okay, you keep I cap j cap same, you use the sign itself, so that already is giving you a unit vector which is in the opposite direction. So remember that we always use I cap j cap k cap as positive only. Coordinate can be positive or negative. Okay, that is one very important sign convention. J cap is unit vector along y axis, and k cap is unit vector along z axis. Okay, so these are the 3 unit vectors that you need to know in detail, right? So if you know these 3 unit vectors, you will be well and good. You can basically construct any vector. Any vector is possible using xyz. Any position vector you can denote using xyz axis, right? If you know the coordinate x comma y comma z, it will be xi cap plus yz cap plus zk cap. Now they have certain properties of themselves as well. We will learn about that later on. Okay, now let's move on, but first of all, x is I cap, y is z cap, and j cap, sorry, y is j cap, and z is k cap. So I cap, j cap, k cap, 3 unit vectors, and it is globally same for everywhere. Okay, it's like SI unit. Okay, it is same for everywhere, no matter wherever you go in the world. I cap, j cap, k cap refers to unit vectors. There is no separate symbol for them. Okay, now multiplying a vector by a real number. So real number means what? Real number means 1, 2, 3, 5.2, 7.8, any number, okay, which are not complex. They are all real number, positive or negative. Okay, so if you are multiplying a vector with, say, a constant which is greater than 0. Okay, real 0 is also a real number, right? So it's greater than 0 means you are multiplying 1.59. Okay, just for example, if you multiply a vector with a real number and if the number is greater than 0, you get a vector in the same direction, but its magnitude will be increased by the factor. Suppose original vector was, say, 5, okay, in the east direction. Say original vector was 5 in the east direction. Okay, and now the new vector will be, say, you are doing 2a, so it will be 10, and it will be also along the east direction. So the same way, multiplication as we have done in case of normal multiplier case, 2 into 5 is 10. So here also 2 into 5 is 10, and if the value is greater than 0, then the direction of the vector will be along the same direction as it was before. If you multiply with a negative number, if the number that you are multiplying is a negative number, okay, the magnitude increases by the factor of the multiplier, but the direction is opposite. Okay, direction reverses magnitude scaled by lambda times. So lambda is a constant. So suppose lambda's value is 1.5 minus 1.5. Okay, if you take lambda equals to minus 1.5, it's a scalar quantity. Okay, but when you are multiplying this, because of this negative sign, the final vector sign reverses. So that is very important. The vectors are no longer in the same direction. Here the vectors are in the same direction, only magnitude changes. Here magnitude changes, direction also changes. So that is super duper important, and that's why it is different than that of the scalar multiplication. Scalars, we do not need to worry about direction. Here we need to worry about direction as well. Okay, and it's a vector quantity. Let me denote it like this. Okay, now if the value is 0, when you multiply with 0, what happens? Okay, if you multiply with 0, the final answer becomes 0. The resultant is a null vector. Null vector. Okay, 0 magnitude, no specified direction. Okay, so that kind of quantity is called 0 vector. Even 0 can be a vector. That is super duper important. Okay, when you multiply one vector with a 0 scalar, the resultant is a 0 vector. It is not a scalar quantity, by the way. Even though its magnitude is 0, even though its direction is not specified, it is still a vector. Remember that this is still a vector. So it is basically a vector with 0 magnitude. In vector quantity, in vector geometry, okay, 0 vector plays a very important role, because in many cases you will see that when two vectors are added or subtracted, okay, we are supposed to get some value along with direction, and the final result has to be a vector quantity. But if addition, subtraction or multiplication, if the final result is 0, okay, you cannot say that because the parents or the quantities which are merging are vectors, at least one of them are vector in multiplication or division, okay, but the multiplier can be 0, Because of that, we are getting a 0 answer. Okay, that means the final answer has to be a vector quantity. Okay, and that's why there is a concept of null vector. So the null vector is super important. Remember, what is a null vector? It can be asked as a 2-marker question. Okay, you need to write the definition and give one example. There are 2 examples on this. One is multiplication, another one we will come just a while. Okay, so remember that null vector is a vector having 0 magnitude and no specified direction, then it is called a null vector. Okay, 0 magnitude but no specified direction, then it is called a null vector. You can give 2 examples. One is multiplication. Okay, you can take this example. Okay, a plus 0 is a. Some books mention null vector like this, but you can add 0 vector. You can write a 0 and put a vector sign on top of that. That becomes 0 vector. Okay, that is a 0 vector. This is an example of 0 vector. This is a 0 scalar. This is a vector. So 0 into a vector gives you 0 vector. Okay, 0 vector multiplied by a scalar will give you a 0 vector. Okay, so 0 vector is always something which has 0 magnitude, but it's still a vector quantity. This is slightly tricky, but anyway. Now addition of 2 vectors, graphical method. So you can add vectors not like normal 2 plus 2 is not equals to 4. Okay, so how can you add 2 vectors? That is super duper important. The only way to add 2 vectors, you have to use one of the 2 graphical method. One of them is a triangle method. So what is a triangle method? You take the vectors a and b. Okay, take the first vector. Suppose you are trying to find r resultant r a plus b vector. Okay, suppose a has value 2, b has value 3. Okay, what will be the r value? You think the r value will be 5? No. 2 plus 3 is not 5 in vector addition. That is super important. That's what I am saying. Okay, suppose the angle between the vector is theta. Okay, so when you are finding the angle between 2 vectors, remember the vector has to be like this. The vector has to be like this. If the vectors are not like this, then you need to extend the vector so that you get the vector on the same direction. Okay, the angle has to be like this. Okay, so whenever you are trying to find the angle between 2 vectors, the angle has to be the arrows should be outward. The arrows should be outward. Okay, if they are finishing like this, then you need to extend another one so that the arrows becomes outward and you get the angle. This is how the angle between vectors are measured. Very important point to remember, because many cases, some cases students start taking this as the angle. This is wrong. Okay, this is not the angle between vector. Angle between the vector is this, because you have to extend this line. This arrow ends over here. So you need to extend this line so that you get the angle between this extended line, which has a sense of direction in the same direction of vector A. B vector is fine. Okay, it is pointing from there. So that means this is the angle. So whenever you measure the angle between 2 vectors, make sure the vectors are either drawn from the same point, or if they are not, then you need to extend one of the line and find the angle. Okay, this is how we find the angle between 2 vectors. So anyway, so 2 vectors A and B, angle between them is theta. Okay, and you are trying to find this resultant. Resultant is basically triangle method. What is the triangle method? Place the tail of B at the head of A. R runs from the tail of the A to head of the B. So if you take this as A, this as B, okay, so wherever A ends, the vector B starts from there, and whatever vector completes this triangle, starting from the starting location of the first vector to the ending location of the second vector, that gives you the resultant vector. Okay, this is the triangle law of vector addition. Very important. You need to remember in the exam, 2-marker question might come from this. Now what? So what will be this value a plus b? I am saying 2 plus 3 is not 5 or 2 plus 2 is not 4. Then what is the value of 2 plus 2? So that means here the vector addition, it can be proven geometrically. The geometric derivation is not there in the syllabus. I'm just telling you the value of r. Generally this is the sign of the magnitude. This is called mod. This is called mod. Mod means only the value. Only the value. So r vector is given by square root of a square plus b square plus 2ab cos theta. Yes, cos theta. So the angle, you need to find the angle for the vector as well. Now what is the angle this resultant vector is making with the first vector? So that angle will be tan phi is given by, so you are measuring the angle with this vector, so you need to consider the second vector first. It will be b. Now what is tan? Tan is sine by cos. Here it will be also sine by cos, but in terms of theta, okay, just to be careful. And in the division it will be a plus b cos theta. Okay, so tan phi equals to b sine theta divided by a plus b cos theta. Now how to remember it? To remember, you need to remember that you are finding the angle with respect to suppose this is the base. Okay, you need to consider this other vector. So this vector is not related with phi, so this vector's sine divided by this vector cos in terms of theta, and in the denominator extra this a will be added. Okay, this can be proven geometrically. Obviously we are not doing it. This is not part of the syllabus. If you want this derivation to be done, mention in the comment section below. I will try to add in another separate video. Okay, now if you are adding the vector, there is another method of addition of vector, which is parallelogram law. So here you need to draw a parallelogram. Bring both tails to O. R is the diagonal of the parallelogram O. The two methods are equivalent. So the triangle method and parallelogram method, they are equivalent. Now what you have to do here, both the vectors needs to be drawn from the same point. If you draw both vectors A and B from the same point, okay, then the diagonal which passes from this common point, and if you construct a parallelogram consisting of A and B, okay, and the diagonal which is passing from the point O, that diagonal gives you the resultant vector. In this case also, if you try to figure out, the values will be same. Okay, the formula for resultant, it is always same, which is square root of a square plus b square plus 2ab cos theta. Now if you see here in this particular method, the angle A and B are drawn from the same point, so this will be your theta, okay, and this will be your phi. Again the method is same. The phi angle is adjacent to A, so you need to leave and go back to the other vector. Okay, so R, the formula is same, a square plus b square plus 2ab cos theta, and tan phi equals to b sin theta by a plus b cos theta. Okay, so no change in the formula. You can draw a perpendicular along this and then calculate it. Okay, this can be done in very easily. Okay, you can even see this is, if this is b, this vector will be b, and you can calculate the resultant as well as the angle as well. Okay, now vector addition is commutative in nature. What is the meaning of commutative? Suppose you are doing a plus b, okay, and you are doing b plus a. If that law is valid, that is called commutative. Now you might say, sir, this is very obvious, no? But in many cases you will learn throughout your journey 2 plus 3 and 3 plus 2 may not be equal. in some cases. Okay, commutative means if you are adding the things like A and B as well as B plus A, that gives you the same answer. Okay, one such example, you will learn it in future chapter, cross product of vectors. So A cross B is not equals to B cross A. Okay, so vector multiplication is not commutative. Okay, in fact vector has two different types of multiplication. Okay, so that is one example I can give you. So you will learn more in mathematics also. So not always so far it seems very obvious to us, right? 2 plus 3 is 5, 3 plus 2 is also 5, but it may not be the case in some cases. Because vector is a very special case, we have to specify that. Similarly, if you are doing A plus B first and then doing plus C, or you are doing B plus C first and then doing plus A, the result should be same. The result should be same. Okay, it does not matter. It is called associative nature of vector addition. Okay, this is all about vector addition. Associative nature and commutative. Vector additions are commutative as well as associative. It is more like mathematics. You will learn vector in mathematics. There these properties will be much more important and you need to learn a lot more there. Okay, now as I mentioned, null vector. What is a null vector? Null vector, I gave you one example when you are multiplying 0, right? A into 0 is 0. Now when you are adding two equal vectors in opposite direction, if you add two equal vectors in opposite direction, the resultant should be 0. Okay, that is also an example of null vector. This is also a null vector. So null vector, I told you there are two examples. One is, this is example 2. Example 2. Okay, first example is multiplying with a 0 and second example is adding two vectors having same magnitude but opposite direction gives you null vector. Now that leads to our next topic, which is subtraction. So if they are equal, we get null vector. What if they are not equal? If two vectors are not equal, then how can we find the resultant? So one easiest way, there are few ways to do that. One easiest way, suppose you have a vector. Okay, you have a vector A, you have another vector B. One easiest way is take a negative of this vector. Negative of the vector means how to take a negative of a vector. If this is a positive vector, then exactly equal will be negative vector. If the vector is already negative and you are doing a subtraction, you need to take negative of negative, which will be positive. So anyway, the same way as mathematics, only thing you need to consider is that you need to consider a vector which is opposite to that vector. So this will be my minus b vector. Now you add them. Now you add them, you will get the resultant, which is actually it is an addition vector, right? This is an addition. What we are doing, we are adding a vector A with minus b, right? We are adding vector A with minus b. So resultant in this case is A minus b, right? A minus b. Now everything will be same. Okay, resultant will become, what is the magnitude? It will be A square plus B square plus 2A minus B cos theta. Okay, or A square plus B square minus 2AB cos theta. Okay, here angle is when you take the extend the vector. Okay, this is the angle theta. This angle theta we are considering. Okay, so this is a very important point. You need to remember that whenever you are adding two vectors, the resultant is A square plus B square plus 2AB cos theta, and the angle, the resultant's angle, say phi, tan phi, equals to minus b sin theta by a minus b cos theta. Okay, or if you multiply minus b sin theta by b cos theta minus a. Okay, you don't need to worry too much. Only in the formula you put b is equal to minus b and everything will be same as that in the addition case. Okay, there is one more way I'd like to teach you that you can apply is that suppose you have two vectors a and b. Suppose this is a vector, this is b vector. You are trying to find a minus b. You would start with the first vector. You are trying to find a minus b. So b is minus. So you start at the negative vector. Join this. This will be a minus b. So a is bigger, b is smaller. So it will point from a minus b. Okay, so from smaller vector towards larger vector. So this is a triangle addition. This is another method. Here we have taken the reverse of the vector and we have applied everything that we know. Okay, right? So this is an example of addition. So reverse the vector b and add them as triangle law. Okay, same as triangle law. Now zero magnitude, its direction cannot be specified, is null vector. Another example of null vector is that if you are going in a round trip. So round trip, if your starting point and ending point are same, then also the displacement is zero vector or null vector. Okay, so these are the examples of null vector. So just another example. So this is example 3. This one we have said example 1. Okay, example 1 is when you multiply a vector with 0, you get null vector. You subtract two equal vector, you get a zero vector. You complete a round trip, then also you can get a null vector. Anyway, now let's move on with another very important point, which is called resolution of vector. Resolution, New Year resolution. So same with the vector. Vector has taken a resolution long back. Okay, resolution of vectors. Basically it's not the same resolution, but anyway, suppose this is my x-axis, okay, now we have, this is my y-axis, now we have a vector. We have one very simple vector, very cute vector, which is this. We are calling this vector, say, a vector. Now what we are trying to do is this, understanding this vector is difficult. Okay, this is one single vector, and in many cases we need to have a lot many vectors. Okay, and we will be struggling to add them in a normal method of addition. Okay, normal method of addition can be tricky if you are adding, say, 3 vector, 4 vector or 5 vectors. Okay, the normal addition method is difficult. Okay, that's why we generally use a very simple method, which is called resolution. What is the meaning of resolution? Resolution means when a vector is given to you, we go to its end position and draw projection along the x-axis. Okay, from the vector to the x-axis and from the vector to the, from the vector to the x-axis and from the vector to the y-axis. Okay, so these two are called projections. Okay, this portion starting from origin O is called x component of this vector. This is called x component of the vector, denoted by symbol a suffix x. This length is called y component of the vector and denoted by ay. This is called ay. Okay, so these two are called resolution of vector A, or resolved. Vector A resolved into x and y components. So x and y, ax and ay are x and y components of vector A. X and y are components of vector A. Okay, so when you are given a vector, you take two separate portions out of this vector. Okay, then those two separate portions are called components of A. Now why they are called components? Because A vector, magnitude of A vector can be calculated by Pythagoras theorem, ax square plus ay square. Right, this is the right angle triangle, this is ax, this is ay, so this is also ay. So ax square plus ay square is equal to a square. So a equals to square root of ax square plus ay square. So this is the magnitude wise. Now direction wise, the entire vector A can be written as ax I cap plus ay j cap. Okay, I cap j cap are unit vectors. So unit vector along x I told you is I cap, unit vector along y axis I told you j cap, and along z axis it is k cap. Okay, in some cases we may need to do a three-dimensional resolution. Resolution is not limited to only two-dimensional resolution. In many cases we may need to resolve a vector into three-dimensional resolution as well. Now when you resolve a vector into two components, there are few benefits of it. Okay, for example, when you resolve a motion, okay, into two different perpendicular motions, okay, these two components can be treated independent of each other. Okay, they are linked but still they are independent. Okay, we will see that when we are doing projectile motion. So this component and this component, they are perpendicular to each other. Two vectors, when they are perpendicular, they are individually, they can be considered independent of each other. So whenever, whatever law we can apply on this, okay, the different law we can apply on this based on situation. Okay, so they may not be related to each other directly. There are some relations. For example, in projectile motion, they are linked with time. They are not linked to anything else, but they are linked only with time. Okay, but the motions are independent. We'll see that. So resolution is basically a way of expressing a vector. Resolution of vector is basically take one vector, you divide them into two different components. That is called resolution of vector. Okay, so basically one vector when divided into two separate components, those two components are called components of vector A, and this method is called resolution of vectors. Okay, or resolving a vector into its components. So resolving this vector A into its constituent components, that is called resolution of a vector. Okay, so in terms of three dimension, okay, this can be written as ax I cap plus ay cap plus az k cap. Okay, and magnitude becomes square root of ax square plus ay square plus az square. Now this ax and ay can be calculated using the angle theta. If you know that how much angle it makes with the x-axis, you can actually calculate the x component and y component. Now there are a lot of ways to remember it. I will tell you the most important way to remember what is this theta, and based on that how can you identify which component it is. So this might come in many cases, okay, in future when you are doing laws of motion. And if you have a doubt in here, okay, all your upcoming chapter will be troubled. Okay, all of your upcoming chapters will be in trouble if you do not understand how to find the components, x and y components. So if one angle is known, always remember the adjacent component. Adjacent component. Adjacent component, what is adjacent component over here? Adjacent component to the angle, theta. Okay, so what is the angle here? Angle here is theta, and what is the adjacent side? Adjacent here is x. Remember, adjacent here is x. It could have been y also. If you are taking that angle, it could have been y component also. So don't have any prejudice in your mind that it is always x-axis, the theta has to be always x-axis, or theta has to be along the horizontal. It can be any general direction. I will give you one example after this. Okay, so you only have to remember that if you know this angle, these two axes are perpendicular to each other. This is my mother vector. So this component, the x component, can be written as ax equals to mother vector, okay, magnitude of the mother vector, cos theta. Okay, adjacent components are always a cos theta. Okay, and the perpendicular component, if this is adjacent side, this is perpendicular side. That is, in this particular case, this is ay, that will be given by a sin theta. Okay, clear? Always remember, adjacent component is always cos theta and perpendicular component is always sin theta. No matter what, when two vectors are being resolved into components, you will get two components, x and y. The component which is along the angle, which is nearest to the angle, okay, or adjacent to the angle, that component is always cos theta component. The component which is perpendicular to this angle, that will be sin theta. Obviously the angle will be given to you based on question to question. You need to adapt and solve it. Now let me show you one general topic, that general component of vector that I was saying. Suppose we have a vector, okay, we have a vector this, okay, the axis that we are going to consider over here are not x and y axis. Suppose this is my one axis, okay, let me rotate it. Okay, this is one axis, another is this. So if you see that these two axes are actually perpendicular, right? These two axes are, they are perpendicular, right? So that means any two perpendicular axes, you can always find the resolution of vectors. So here you need to do the same thing. You need to draw a perpendicular on this, okay, then take another point, draw perpendicular on this. Only condition is that these two has to be perpendicular. So okay, I think this line is not perpendicular. Just give me a moment. This is perpendicular now, and yes, so you just need to be careful that these are perpendicular. Okay, these are perpendicular, then everything is fine. They need not to be our conventional x or y axis. This is our conventional x and y axis. It not necessarily need to be this. Okay, it can be any two perpendicular axes along which you can take resolution of vector. Now if this angle is known to you, suppose this angle is given to you phi, okay, this vector is say a, okay, a vector, then this will be, this component is our adjacent component. This is our adjacent component, so this will be a cos phi, and this will be a sine phi. Do not keep any prejudice or any misinformation in your head that only this component is x cos theta, only this component is sine theta. No, always remember the angle to which is given to you, based on that cos and sine are determined. If this angle is given to you, the component which is next to this angle is cos theta. If this angle is given to you, this will be cos theta. Here this angle is given cos theta, other one will be sine theta. Okay, always keep that. And the axis may not need to be based on our x and y axis, it can be any general axis as well. That is the beauty of resolution of vectors. Okay, now now when you are adding two vectors, normally when you are adding vectors, the addition formula is r vector equals to square root of a square plus b square plus 2ab cos phi. That is the normal formula when you are adding two vectors, right? Now there are other ways to add two vectors, which is basically, suppose we have two vectors, say a vector equals to ax I cap plus ay j cap. Okay, another vector, say b vector, it also have two components. Y, even though I said x and y are not necessarily in case of resolution, but when you are writing a vector in their coordinate form, geometric form, this is geometric form of a vector. Okay, in that case always x and y are compulsory, but resolution of vector you can do it any two perpendicular axis. Okay, so that is one slight correction that I want to make. Okay, now when you are representing a vector in the coordinate form, okay, and if you want to add them, the addition is very simple. So if you want to add them, a plus b, what you will get? You will get ax plus bx. So basically all the components having the same unit vector gets added. Okay, and all the vectors with y also gets added. So ay plus by j cap, and it also includes the sign. Suppose in some cases one of them is negative, you just take the sign negative and add them, and in this case you can add 10, 20, 30 vectors very easily. Only x components will be added, y components will be added, z components will be added. So based on the vector, okay, only the components gets added. Let me add the z component as well, because z component is also sometimes being asked. So az k cap plus bz k cap, when you are adding them, only the components gets added. So it is az plus bz k cap. Okay, so remember that whenever you are adding two vectors in xyz component, it is much easier than directly adding the vectors using formula. Okay, now once you get this value, suppose this value is 2, this is 5, this is 7, then how to find the resultant, exact value of the resultant? So if you try to find the resultant vector, that will be square say modulus of this a plus b. Now this is also very easy. You don't need to have anything. What is the angle between these vectors? What is how these vectors are oriented? You don't need to know that, all these information. Only thing you need to do, x plus bx whole square plus ay plus by whole square plus az. Now remember, you don't need to remember all this, just remember the process. Okay, because at the end of the day the values will be given to you, only you need to use this formula. So you get 2, 3, 5, 2 square plus 3 square plus 5 square. So at the end you only need to do that much. Okay, you don't need to remember these values, remember these formulas. You just need to understand that whenever a question is being asked, say some values will be given x, ay, az, okay, and at the end of the day they will tell you what is the magnitude of the vector. You just need to find this. Okay, and for two vectors you can even find the two components, you can even find the angle as well. For three it is slightly tricky to find the angle. Okay, so find the angle between these two you can calculate using tan alpha is equal to b sin theta plus ab cos theta. So this is the normal angle, right? But when you are adding them in component method, suppose you are adding them using two vectors, two components. Okay, now let me imagine that z component is not there, so you can even find the angle theta, tan theta equals to ay plus by by ax plus bx. This is the angle theta with the x axis. Okay, this is the formula that you can use to find the angle with the x axis. If three components are there, you need to find at least two angles, one with the x axis, one with the z axis. Okay, otherwise that is not sufficient. Okay, but yes, mostly you will be given two vectors, two components, only x and y. Z components will come when you are learning multiplication of vectors. In multiplication of vectors, especially cross product, which you will learn in rotational motion, there you need to learn about z component, how to handle it, how to do the multiplication, because that requires certain little bit of determinant method to add. Okay, so these are the these formulas we have already discussed. Now remember that another point I want to make over here, the maximum magnitude, the maximum magnitude of resultant, max value of resultant when the theta is equals to 0 degree. Okay, the R value is maximum when theta is 0 degree, that is vectors A and B are in the same direction. Based on that, 2 or 3 marker questions are being asked in the past, so that's why you need to know that. So they are asking you that 2 and 5 vectors are there, what is the maximum and minimum possible resultant. Okay, so those kind of questions will also be asked. So maximum resultant is there when the vectors are in the same direction, angle is 0. What is the minimum value? Minimum value of the resultant is when theta is 180 degrees, that is the vectors are in the opposite direction. Vectors are in the opposite direction, then the resultant is minimum. Okay, anything between 0 and 180, the value will be between this maximum and minimum value. Okay, so as I mentioned, 2 plus 2 at this stage, 2 plus 2 is 4, and at this stage 2 plus 2 is 0. Okay, so basically because the vectors are in opposite direction, if you are adding two vectors in the opposite direction, then their resultant becomes 0. So 2 plus 2 can be 4, 2 plus 2 can be 0 as well in vector addition. So that's what super important. That's what I always put a little bit pressure on, why 2 plus 2 is 4 is not so simple always. Right, now let's move on with velocity acceleration in 2 dimensions. So velocity and acceleration we have learned in 1 dimension, right? Now we will learn how to use the same concept of velocity and acceleration in 2 dimension. So what is 1 dimension? In 1 dimension, the object is moving, suppose we have seen that if an object is moving, say, in a straight path, that is motion in 1D. So all these equation of motions that we have learned are applicable for this. Now if the object is moving, suppose we have, this is x, this is y. Okay, object is moving, suppose something like this. So what will happen in these cases? Okay, so it can be a constant, it can be basically a path which is not along x or y, it is a straight line graph, or it is like a curved graph. In both cases we need to use motion in 2D equation. So what is motion in 2D equation? Motion in 2D equation is nothing but applying the same thing, same equations, but individually into the components. That's it. Nothing else, no rocket science, nothing new that you need to know. Equations of motions do not change. Equation of motion remains same. Only thing is that you need to apply those individually on x component and y component. Okay, I will explain. Suppose what is velocity? Normally velocity is given by change in displacement by time. So that is dr by dt, that is normal velocity. Now when you are talking about in vector notation, velocity is given by vx I cap plus vy j cap. Okay, that is a what should I say, that is standard two-dimensional motion. Okay, now here the x component is given by rate of change of x only, and vy, the y component, is rate of change of y only. Okay, the velocity's magnitude is given by square root of vx square plus vy square. Okay, so how do we apply everything, how do we apply the laws, etc., we will see that. But before going into that, basically when we talk about velocity, okay, velocity can have a component. So suppose this is my x and y, this is my velocity in a two-dimensional way. Okay, it will have a x component of velocity and a y component of velocity. Okay, so this is the x component of velocity, this is the y component of velocity. Now in these cases, what we can do, we can say that whatever law is applicable on x component is independent on whatever law is applicable to y component. They can have separate conditions as well. For example, in this direction maybe acceleration is there, in this direction acceleration is not there. So there can be multiple cases, and we have to apply the equation of motion individually on x and y component. Same thing goes for acceleration as well. A x component of acceleration is dvx by dt, and y component of acceleration is given by dvy by dt. Okay, that's it. Okay, everything is same, only we need to apply the laws individually. So normally what we do, this is the equation, v is equal to v naught plus at. Okay, this you can write in vector notation as well. Okay, and when you go into the component form, what does it mean? Vx, x component of velocity, final velocity, x component of final velocity equals to v naught x, that is the initial velocity along x component, and axt, that is the acceleration along x component. Similarly, the same equation, if you see the same equation we are using for x as well as y. There is no difference in x component and y component as well. Okay, there is no difference in x and y component. Only thing is that equations are same, the time is same. More important part is that the time is actually what binds these quantities. Only based on the question, suppose you are given that velocity is given by 3 I cap plus 5 j cap. So based on your initial condition, this ox, ax, ay, they will change. These values will be different. Equation will remain same. The structure of the equation remains same. Values will be different. Based on that, you will get two different components, x and y components. But remember that equation does not change because you are writing it is for vector. Okay, and in terms of position, okay, here one extra term that comes is r naught, assuming that the particle is not starting from the origin, it already there at some position and it is starting from there. So that's why we are adding a initial position of the particle. Okay, this is the velocity, this is half at square. Okay, same goes for x here as well. X equals to x naught, x component, let's not write vector, x component is x naught, initial x component of the particle. Suppose the particle was not at the origin, the particle was not at the origin but at some position, say x naught, y naught. Okay, and from here it moved to say x comma y. Okay, then we need to add these to our equation. These values should be added to our equation. So x naught voxt plus half axt square, okay, and y is equal to y naught voyt plus half at square. So this is what only you need to change, okay. S is equal to ut plus half at square remains same, v is equal to u plus at also remains same, okay. V square is equal to u square plus 2as also remains same, only they needs to be added according to the components only. Motion in a plane can be treated as two separate simultaneous one-dimensional motions with constant acceleration along two perpendicular directions, okay. So basically when you are talking about motion in 2D, you can break them into two components x and y. That is why I was so putting lot of effort on explaining what is resolution of vector, because if you know resolution of vector, your life becomes easier, okay, because you can divide a complex two-dimensional motion into two single one-dimensional motion, and all the laws, all the equations that we have learned in the previous chapter are equally valid if you convert them into one-dimensional motion. Two-dimensional motion as it is, you cannot apply the simple equations of motion that we have learned in the previous chapter. To apply the previous equations that we have learned, you need to make it a one-dimensional motion. Okay, you are a two-dimension. Okay, I will take you along x, I will take you along y. Okay, x is one dimension, y is one dimension. I will apply the equation on you. Whatever happened to you in as a whole, I do not care. Okay, that is the beauty of this resolution of vector. Now, one important point I want to remind you about resolution of vector. When you are doing resolution, just remember, I forgot to mention that during my explanation. Suppose you are resolving a velocity vector or any vector into two components. So this is x component, okay, this is y component. Okay, the original vector can be calculated using this, okay, square root of the original vector's magnitude, okay, vx square plus vy square. This is the Pythagoras theorem. We have done it for vector addition, but this is also true for resolution of vectors as well. Sometimes can be handy when you are you resolve the vector into two components, you solved it. Finally, when you are trying to find the magnitude, you need to add them like this to find the final magnitude. Now we are going into the explanation, another super duper application of two-dimensional motion, which is projectile motion. So what is a projectile motion? Projectile is any object flight after being thrown, football, cricket ball, stone, which moves under the action of gravity, which moves under the action of gravity only. Okay, so if you go back to our previous chapter, there was one motion which was only under the gravity, when an object is dropped from a position and allowed to fall only under the gravity. That was called free fall. That is a one-dimensional motion. Free fall is a one-dimensional motion. Here we are talking about a two-dimensional motion, and let me draw the axis. Just give me a moment. So this is my y-axis. Just give me a moment. This is my y-axis. Now this is my x-axis. Let me draw a little bigger. Okay, now this is my x and y axis. Now what? Now I have a object which I want to throw like this. Okay, I have a aeroplane that I have made. I want to throw it. Okay, it can be a cricket ball also. You want to throw the cricket ball towards your friend who is standing a little bit far. Okay, so what you have done, you throw it something like that. Obviously you do not do not throw like this, okay, or you do not throw like this. If you are doing this is only x directional motion. If you are doing like this is only y directional motion. So you throw like this, okay. Whenever we catch a ball or playing cricket, we throw like this, okay. Or when you are throwing an aeroplane, you throw like this, okay. Do you throw up aeroplane along the ground? No, right? So whenever you are throwing or giving a velocity, the velocity is in a two-dimensional way, right? Now here something very interesting happens. First of all, when the object is being thrown, there is a gravitational force acting on this object. There is a gravitational force acting on this object, but that gravitational force is only along y direction. The gravitational force is only along y direction. Along the x direction, there is no acceleration. Along the x direction, there is no acceleration, right? When you throw a ball, only you are basically using some sort of gravitational, you are throwing it against the gravity, then gravity is assisting it. So basically gravity cancels this, right? But it's convenient for us to throw object like this, okay. Every ancient technology, for example, cannons, okay, then mortars is also like a cannon, then trebuchet, they all had this technology which is very in ancient technology. People learned about projectile very long time back, and they realized, okay, if I want to hit a target from a distance, how much speed I require from my side to hit the target. If I give it a slightly less or more speed, it will not hit my target. So that is one important point, and that's how they realized as well. Now the thing is how projectiles are working. So that's what we will find out. So first part is so this is my velocity vector v, okay. This is my velocity, okay. What I will do, I will take this velocity and I will take two components of this velocity. One velocity is along this direction, okay. Let me use dotted line only, okay. Let me use dotted line. So this is one dotted line, this is the x component of velocity, okay, and another one is along this direction, this is my y component of velocity. So this is my x component vx, this is my y component vy. Now if you see that when you throw this object, what will be the path traveled by this object, okay. The path traveled by this object will be like this. Oh, sorry. No, I cannot do that. The path traveled by the object will be like this. This will be the most common path. Just to give emphasis on the velocity, I am taking this. Later on I will add the path taken by the object, which will be like this, okay. Now when you are talking about path taken by the object, how do we trace this path? First of all, we have two objectives. First of all, we have to trace this path and find out what this shape is. Is it a circle? Is it a parabola? Is it a hyperbola? So those things we need to figure out. Is it a part of ellipse? So that is one important point. What is this shape? Is it a, if you take it, will it be a circle or something else? So that is one point, okay. Secondly, what will be the maximum height from the ground it will achieve? So say this is the maximum height from the ground. What is this maximum height? And what is the maximum distance the object will travel along the ground? So these are the three things that we have to find, and also the time, the total time of flight. So how long it was in the air. So starting from here t is equal to 0 and up to here t is equal to t. So this time we have to figure out. So these are the four important parts. First of all, find out what is this graph's nature, what is the nature of this graph. Secondly, what is the maximum height, what is the range, horizontal range. It is called horizontal range, the distance that is traveled by the object along the horizon, that is horizontal range. And then what is the total time, Okay, and we will first start with the nature of this. Once nature is done, then we have to figure out the time, then remaining two you can calculate directly. First step is to find out what is the nature of this graph or this curve. So how to find the nature? Obviously this is called a parametric method. We will be taking an arbitrary point. We'll be taking an arbitrary point and we will call that point as take a point and call it x comma y, random point. It is not very specific point, it is only x comma y. So just like you are given a coordinate system, you take a point x comma y. So this is the x comma y on this graph itself. This x comma y is on this curve itself. Okay, so if we can figure out what is the relationship between x and y, then we can say what is the nature. For example, I'm just giving you an example. Y is equal to mx plus c. If we find the relationship is like this, okay, then we can say that this is a straight line equation. If it is x square plus y square equals to a square, similar to that, then it will be a circle. Okay, so based on the equation we can tell what is the nature of this graph, right? So we will figure that out and we will see that what is this nature. But first let us understand what is the x component. So this angle, suppose this angle is theta, this is called angle of projection. This angle is called angle of projection. Angle a projectile makes with the horizon or with the ground. Okay, this is the ground. This is same as ground or horizon. So if you are throwing from some point above the ground, then horizontal direction, or if you are falling down on the ground and throwing it, for example a cannonball, okay, mostly it is thrown from the ground almost, right? So those are taken, that angle is important, either horizontal angle or from the ground the distance. Okay, that angle is theta. Now what is the x component? So as I explained few moments back, x component here is the adjacent side. X component is adjacent to the angle theta. That means x will be v cos theta and y component will be perpendicular, that is v sin theta. Okay, v cos theta and v sin theta. So this component will be cos theta, this is cos theta component, this is sin theta component, right? And based on this, what we need to do, we need to figure out what this location of x comma y. Suppose the object took a time of small t to reach at this point. The object took a time small t to reach at this point. This t we do not know. If we can figure out this t, then our problem is solved. Now one very important point, as I mentioned, why do we resolve it into two components? So that we can independently apply equation of motion on these two motions independently, which is very important. They are not dependent on each other except for this time t. This time t is the only common thing between x motion and y motion, because they are part of the same object, right, same velocity. They are basically divided into two components. That means they are basically linked only through time, that's it. They are not linked through anything else. So Vx and Vy we have calculated. Okay, the gravitational acceleration is only acting the y direction. Along the x direction, acceleration is 0. So we will use the equation of motion. What equation of motion? Suppose at this distance, what is this x component? X is this distance, right? Horizontal distance traveled. What is y? Y is the vertical height traveled. Okay, so y is vertical height traveled. So we can write s is equal to ut plus half at square. So it will be vyt minus half gt square. Why, sir, minus? Because this component of velocity is upward, gravitational acceleration is downward. So because the direction of y and g are opposite, that's why there is a negative sign. Clear? Don't make any mistake over here. Now, so this is the y coordinate, right? So y equals to v sine theta into t minus half gt square. Let's say this is my equation number 1. Okay, now let's go and check the x component. Y component is done. Now what about the x component? X component will be given by their acceleration through along the x direction is 0. Okay, acceleration through y direction is minus g. Okay, acceleration through x direction is 0. So s is equal to ut plus half at square. Half at being 0, it will be only simple ut. So it will be vx into t. Okay, or it will be v cos theta into t. Now as I mentioned, these two quantities we are linked through this t. Okay, if we can replace this t, then our problem will be solved. Okay, how can we replace the t? Okay, how can we replace the t? The only easiest way to replace the t is take t from this equation. This is the easiest equation. So t equals to x by v cos theta. T is equal to x by v cos theta. So you take this time t and put them back in the equation number 1. So say this is equation number 2. You take this t and put them in equation number 1. So you get y equals to v sine theta, okay, v sine theta into x by v cos theta into x by v cos theta. Now if you see here, this equation do not have any time t. Okay, so time, we are trying to free up our equation and we are removing the time t so that our equation becomes free of time. That will give us general equation. Okay, so this will give us general equation. Now half gt square. So half gt square means x by v cos theta whole square. Right? Now if you see that this v cancels, you get tan theta into x minus half g into 1 by v square cos square theta all in bracket into x square. Okay, or you can write y equals to ax square plus bx. Sir, what happened to this negative sign? Don't worry, because a is a constant, we can take the negative sign inside the constant. So it will be half g 1 by v square cos square theta and b equals to tan theta. Okay, this is a general equation of a parabola. This is a general equation of a parabola. If you have done parabola in your mathematics class, you know that normally parabola equation is given by y square equals to 4ax or x square equals to 4ay, based on you are getting a parabola like this or like this. Okay, so there are two equations, but this is a very specific equation when it is passing through the axis itself. If it is not passing through the axis, okay, it may be a general equation. The generalized form is y is equal to a power of x should be 2 and another power of x should be 1. Okay, one side y to the power 1, other side x to the power 2, and there may be a component which related to x to the power 1. So if you add a y over here also or x over here also, it still becomes a parabolic equation. So the power difference should be, highest power difference between y and x should be 1. Okay, and highest power of y should be 2, highest power of x should be 1. These are the conditions, right? These are the condition of if both of them are square, if you have a y square is equal to ax square plus bx, then that could be an ellipse or a circle, based on how can you arrange them. But circle is a special type of ellipse, so we will say that is a generalized ellipse. Okay, but here one side the y's power is 1, here x power is 2, so that means they do not have the same power. There is a power imbalance. That means this is a parabolic equation. This is a parabolic equation. Okay, so remember that. So this is the step by step. This is a super duper important derivation, and it is almost repeating every year in your midterms, in your pre-boards, not pre-board, in your whatever pre-PUC final. Okay, PUC first PUC final and PUC final, all there, all of these exams. This is one of the most favorite question by the examiners for. So prepare it. It is super duper important. You should not skip it. Okay, so this is the step. Now we have to find a few more things, that time of flight, then maximum height, time of flight, maximum height, and horizontal range. These are the things that we need to find one by one. Okay, again we will go back to our equation, and now I am drawing this by hand because using the tools can take a little longer time. So this is my parabola, so this is my x-axis, this is my y-axis. Now don't confuse between these two derivations. This derivation is also important, the other derivation is also important. So other derivation, we started with a random point and try to figure out what is that random point is, eliminate time t and solved it. Here our goal is very straightforward. We want to know the maximum height, we want to know the maximum range, and we want to know the time of flight. Okay, so this is the component of velocity, this is the particle which is traveling. Okay, just for fun, let me add a separate color. Let me add a separate color for this. So this is my projectile motion. Now when you take the x component, this will be my x component, vx. Okay, the velocity is generally denoted by v. This is my y component, vy. Okay, the angle here is theta. So first step is vx equals to v cos theta and vy equals to v sin theta. So these are the first thing that you need to write. Like when you start your exam, you write your name, roll number, etc. So when you are solving a projectile motion, these things are first you need to write. Okay, no matter whatever is the question, right? So x component, y component is figured out. Now we know that the gravitational acceleration is only acting along the y direction. Gravitational acceleration is only acting along the y direction. Okay, there is no acceleration along x direction, right? Now first step, we will consider only the vertical motion, only the vertical motion. First step is to use the vertical motion. What is the meaning of that? We consider that horizontal motion does not exist for now. Object is moving up and down only. So basically we are considering this motion. Okay, so basically projectile motion, when you throw it, there is this motion and there is this motion. These two motion combined is actually the projectile motion. Okay, so if you are still confused, remember projectile motion, there is a horizontal motion. Horizontal motion means you take a ball and throw it like this. This is horizontal motion, vertical motion. So when you throw an object just up and down, that is vertical motion, and if you take the ball and just throw it along the ground, that is the horizontal motion. So projectile motion is combination of these two motion. One motion is happening in this direction, one motion is happening in this direction, but they are linked with the time. So time is the thing of essence over here. If you can figure out the time, your projectile motion is solved. Okay, if you can figure out the time, your projectile motion is solved. So let's try that. So here this is the velocity which is going up in this direction, right? Now here you need to first consider only the vertical motion, ignoring the horizontal motion altogether. So what will happen? It will go up, and at its maximum position, the projectile will halt momentarily in the vertical direction, same as horizontal motion. If you throw a ball up, it comes to a rest at the top position, then it starts falling back. Same thing happens to a projectile as well. When you consider only the vertical motion. So in the vertical direction, so it has at some point of time its velocity becomes 0. So we are trying to find that point. Okay, so velocity along vertical, say Vy, final velocity is given by initial velocity minus gt. Initial velocity minus gt. Okay, at the maximum height, when the object reaches maximum height, so y equals to h. H denotes to maximum height. Okay, maximum height. When the object reaches its maximum height at this position, what happens? This v becomes 0. So we get 0 equals to Vy minus gt. Vy minus gt. Or what is t over here? T is Vy by g. What is Vy? Vy is my v sin theta upon g. So this is my time. This is the maximum time. This is the time taken to reach the maximum height. Time taken to reach the maximum height is basically given by this time t. Okay, which is given by v sin theta by g. Now if you consider the projectile motion, so basically this is the halfway path. So it is starting from here, it reached over here, and then it reached over there. So this is the halfway point. This is the halfway point, half. So the cricket match is happening. So when the first innings is over, second innings about to start, that is the halfway, midway point, right, in a T20 match. So this is the midpoint. So remaining time, how much? So if the time taken from 0 to here is t, the time taken to here is also t. Because in physics we do not differentiate between this. Now you might say, sir, in matches one innings lasted 1 hour 30 minutes, another innings may last 1 hour 31 minutes. That in physics, that is not the case. Physics do not differentiate. Physics says if this is happening in 10 seconds, the other half will also happen in 10 seconds, exactly equal. So that means total time of flight, what is the meaning of that? Total time of flight, that time through which the ball was in air, the object was in air. So the object was in air as soon as you threw it from here and just before touching the ground. So that's the time the ball was in air, ball or the object was in air. Okay, so total time of flight is that object that it stays in air is given by t equals to twice of this t. Twice of this t, that is given by 2v sin theta upon g. Now if you can calculate these two times, your life is done, your life is sorted. You just need to find the maximum height and range from this time. This is the most important. These two times are most important, this and this. This time is required to calculate maximum height h. This time is required to calculate range r. That's it. Okay. But sometimes in the exam either range or height will be calculated. If they are asking you only height, you only find this time and calculate height. If they are asking you range, after this you have to say what is the time of flight, then you have to calculate the range. So based on question, you need to modify your answer. You do not need to show this time if it is not asked and you are only asked to find the height. So first step is to find the height. What is the height? So when you throw the object, what happens? It starts with the velocity Vy in the y direction. Only y direction and motion we are considering. Okay, when it is moving in the y direction. Okay, so what happens? It reaching the maximum height h. At this position, the velocity is 0. Okay, time taken here is v sin theta upon g. Right, that is the time taken. So what is the height h? So s equals to, or here h equals to ut plus half at square. That is the formula, right? Now here h equals to, what is u? U here is Vy. So it will be Vyt plus half minus g t square. Okay, or now your step is to put the values of t, okay, and vy. Vy is v sine theta, right? That is v. And what is time t? Time t is v sine theta upon g, right? Now you take here minus, plus and minus, minus half g into v sine theta upon g whole square. So the time that we have calculated in the previous step, this time we are putting in the equation, because with this time it reaches the maximum height, right? At maximum height it is reaching only at time t, right? So that is the thing. Now basically it will be easy to calculate v square sine square theta upon g minus half g into v square sine square theta upon g square. Okay, so now what? Now you need to cancel this g, okay, and you get v square sine square theta by g as common. So v square sine square theta by g as common. Here nothing is there, so only 1. Here only minus half, right? So you get 1 minus half is half. So you get v square sine square theta by 2g. 2g is cam. Okay, so this is the height, maximum height by a projectile. This formula is important, this derivation is important, everything related to this is important. Okay, clear? Now let us calculate the range. So what is the range of the projectile? So range is happening now only in the horizontal direction. So if everything is happening in the horizontal direction, okay, and here acceleration is 0, okay, so what is the displacement here? Displacement itself is range, right? So displacement s equals to ut plus half at square. Here it will be vx into total time of flight t, because the particle is taking total time t to reach from here to here, right? So we need to take the total time t, okay, and plus half at square, a is 0. There is no acceleration in the horizontal direction, so you will no need to consider anything here. So range is given by, range is very easy. After this only time you need to calculate a little bit, otherwise it is very easy. V cos theta into 2v sin theta upon g, right? V sin theta by g is half time and 2v sin theta by g is the total time. So now multiply, you get 2v square sin theta cos theta by g, or v square sin 2 theta by g. Why? Because sin 2 theta is 2 sin theta cos theta, right? So 2 into sin theta cos theta is v sin 2 theta. So that's how you calculate the range as well. Okay, so this is the formula for range. So both these formulas, everything is listed at one go over here. Okay, maximum time is this, okay, time of flight is this, okay, the horizontal range is given by this, and maximum height is this. Now I always, after doing this, I always give a question to my students that if horizontal range and range of a projectile are same, exactly the same, then what is the angle of projection? Okay, so the student gets confused many a times. So let's see. So what is the question? That you have thrown an object which is basically this height and this range, they are same value. Then we are asking what is this angle of projection? Okay, that's the question. Now how to solve it? So range is equals to height. What is range? Range is v square sine 2 theta upon g. What is h? H is v square sine square theta by 2g, right? So you need to cancel v square cancels, g gets cancelled. So everything related to theta is there. You just need to find the theta. So 2 sine theta cos theta. So now you break it, equals to sine square theta by 2. Okay, there is a by 2 here as well. So this sine theta cancels, and you get 4 equals to sine theta by cos theta, or equals to tan theta. Okay, or theta equals to tan inverse 4. This is the answer. This is the answer. Okay, tan inverse 4. Remember, this is a easy question. Sometimes they might say that range is twice of the height, or range is 5 times the height. So based on this, every time, no matter whatever the question is, you need to start with this relation. So if this 5 times, you add 5. If it is 4 times, you add 4. If it is half times, multiply by half. So whatever relation is given, always use these two equations, simplify it, and you will get the answer, right? Easy question, not super difficult, just you need to figure out how to solve it. Okay, now another part of this important chapter is that constant speed, ever changing direction. Okay, so here suppose we have an object which is rotating in a circular motion. So uniform motion. So here we have a circle. Okay, now if we have an object which is rotating along the circle in a constant speed without getting accelerated, without getting any change in the speed, I am talking about speed, remember. So it is moving in a constant speed along this path, then it is called uniform circular motion. So that means speed is constant. So if speed is constant along a circular path, circular track, then it is called a uniform circular motion. So around a park, suppose you are visiting your park, evening walk, you see a circular track around the park. So you are running around the park, or it can be a lake also. You are running around the lake. Okay, so when you are running around this lake, okay, you are maintaining a constant speed, then it is called a uniform circular motion. Okay, so uniform circular motion is motion along a circle in a constant speed. Now speed constant does not necessarily mean that it is a constant velocity as well, right? Last chapter we have discussed velocity and speed, they are different. Velocity is a vector quantity. So suppose at this point the boy is running in a clockwise direction. So at top position the velocity's direction is in this direction. At some other position it is another direction like this. At some other position it is like this. Okay, at some other position it is like this. So the direction of the velocity is changing at each and every point. Direction of the velocity is changing at each and every point. So that means what? That velocity is not constant. And if velocity is not constant, there will be an acceleration. There will be an acceleration. Okay, now before going into that, I just wanted to introduce that the magnitude of velocity, by the way, will remain constant. Okay, the magnitude of the velocity will remain constant. So no matter how it is going, its x component, y component will change. So vx I cap plus vy z cap will change, but the magnitude, when you try to take the magnitude of the vector, it will be same everywhere. That means the speed is constant. So magnitude is constant everywhere. That is important. But because of the change in the direction, there will be acceleration that is acting on it, okay, which is called radial acceleration. It is called radial acceleration. So radial acceleration is what? Radial acceleration is if there is a velocity, acceleration which acts along the radius of this circle, that is called radial acceleration. Okay, and radial acceleration, this acceleration will point in this direction. You can calculate it, the calculation was there. You can do that, not an issue. You need to take two very close point. Okay, then you take the velocities, you take this triangle method and say this angle is very small, theta, etc., and you can calculate the triangle acceleration as well. Change in final velocity, initial velocity, subtract it, then divide it by time, and then you get the answer. But that derivation is very tricky. Okay, some colleges might ask the derivation. It is not that it is out of syllabus, it is part of the syllabus, but I personally prefer that if you are not confident enough with this derivation, skip it, because it takes a lot of time to understand, and if you are trying to, it is not that easy also. The derivation is tricky. You need to know a lot of geometry, you need to know a lot of approximation, etc. Then you can find this acceleration. This is called centripetal acceleration. This is called radial or this is called centripetal acceleration. Just a second. Centripetal acceleration. Okay, centripetal acceleration, and its value is given by v square upon r. R is the radius of this path. Okay, acceleration is pointed towards the center. Few things you need to remember, that it is centripetal, it is towards the center. It is always towards the center of the circle, no matter where you are. Okay, this will always be towards the center. Okay, wherever you go, it will always be towards the center. Okay, no matter, suppose you are trying to find here also, it will be towards the center. Okay, acceleration, again magnitude remains constant, but the direction changes for acceleration as well. So acceleration is also not constant, acceleration is also changing with position. Magnitude constant, direction changes. Magnitude is given by v square by r, and this acceleration is mandatory if you want to rotate in a circular path. Okay, if you do not have this acceleration, you will not be able to maintain the circular motion. You will either come out of the circular motion, or you have to increase the or decrease the length. So this acceleration is super important. We will see that why so in the next chapter, laws of motion. There centripetal force we will learn, and we will see why this is important. But now remember, whenever there is a uniform circular motion, because only the velocity's direction is changing, there is a acceleration, which is very interesting, because we do not give too much importance to the direction. We think that okay, scalar quantity, no direction, vector quantity, there is a direction, what else, just with an additional direction it's same as scalar. No, even if the direction is changing, for example, velocity can give rise to acceleration. So if it is happening in a straight line, maybe not, but if it is happening in a circular path, only by changing the direction, acceleration is changing. So that is super duper important point. Okay, and that acceleration here, it is called centripetal acceleration. It is given by v square by r. Now few terms in rotational motion. For example, first is angular velocity. So far we are talking about speed, velocity, etc. Now let us discuss another quantity, which is called angular velocity, omega. And as we are terming it as angular velocity, it is denoted by a vector quantity. Okay, we will see the direction as well, don't worry. So angular velocity is basically what? Angular velocity is a measurement of how much angle it is rotating per unit second. Okay, suppose there are 2-3 different units. I will explain that as well. So first is, suppose the object is rotating. Right? If you want to find the linear velocity, we need to find the distance traveled, then displacement divided by time, right? In case of angular velocity, what is the important part is that how much angle it covers in unit second. how much angle in radians it covers per unit second. That is what important point. But in many cases it has another units. For example, revolution per minute or revolution per second. These are also the units of angular velocity, but most SI unit is radian per second. Radian is the angle and second is per second. So how much angle it covers in unit second, that is called radian per second. So this is the angular velocity. Now why it is important? Because centripetal force can be expressed in terms of angular velocity as well. There is a chapter, rotational motion, where angular velocity is super duper important as well. Now anyway, so revolution per minute, what is that? Revolution per minute means, suppose the object starts over here, it completes and come back over here as well. So this is called one revolution. One revolution means one complete rotation. Okay, if it is completes two revolution. If it is complete 2.5 revolution, that means 2 complete revolution and 1/2, right? So revolution per minute means in 1 minute how many complete revolution it does. Okay, and if fraction represents fraction of the complete revolution. Okay, it need not to be a whole number, it can be a fraction as well. Fraction represents that it completes 3 revolution, but then it moved by a small distance, that is 3.1. So 3.1 revolution per minute means 3 complete revolution and then 0.1 of a fraction, right? So that is okay. Now how to convert revolution per minute into radian per second? Now remember that one complete revolution means this is pi 2 pi. One complete revolution gives rise to 2 pi radian angle. Okay, so one complete revolution gives rise to 2 pi radian angle. Okay, so we know the angle. Now how much time it takes? It takes 1 minute time. So suppose n revolution per time, and it is written as revolution per minute, RPM. Now it sounds familiar. You may have heard 5 RPM, 10 RPM. Okay, those who are slightly gadget freak, those who like to drive bikes, etc., they may have heard this term, RPM. RPM is revolution per minute. Okay, how many revolutions it is doing? Suppose n RPM, that means it is rotating n times in 1 minute. Each rotation is 2 pi radian. So n rotation will be 2 pi into n radian. It will be 2 pi into n radian. Right, this is the total number of angle. Now if you divide it by the time, that is 60 seconds, 1 minute is 60 seconds, then you get radian per second unit. This is the angular velocity. If n RPM, it will be 2 pi n by 60. If it is given in RPS, only need to multiply 2 pi, that's it. RPS is very less used. Most common units of rotational motion, angular velocity, is RPM. Now angular velocity is a vector quantity, angular speed is the magnitude of angular velocity. Now what is the direction of angular velocity? That is another question. Whenever there is a velocity or a vector quantity, you need to find the direction. So what is the direction? How to find the direction? Very easy. Take your right hand, only right hand, curl your fingers in the direction of the motion. Okay, curl your fingers in the direction of the motion, then your thumb points the direction of angular velocity. If it is clockwise, here you can see it is into the page of the paper. If it is anti-clockwise, then it is out of the paper. So angular velocity is a vector quantity and you can find its direction based on the motion. Okay, curl your fingers in the direction of the motion, then your thumb points the direction of angular velocity. For example, now next time try to find out the the angular velocity for a rotating fan. Okay, angular velocity, direction of angular velocity for a rotating fan. Based on that, there was a question in KCET 2024. Okay, so that's very interesting. Even though that is not there in this chapter, in future we will study, but yes. Okay, angular speed, normal formula is v is equal to theta by delta t. Now there is a relationship between angular speed and linear speed. The relationship is given by v is equal to omega r. V is equal to omega r. R is the radius of the motion. Okay, and you can even calculate that the centripetal acceleration in terms of angular velocity. So angular velocity is given by r omega. I am writing small r. Okay, don't worry. So r is the radius. R is the radius. Then the centripetal acceleration becomes omega square r. Okay, you just need to put here, okay, you just need to put the value of v from that equation. V is equal to r omega, one of the r's will be cancelled, you get omega square r. Okay, omega square r. This is the angular centripetal acceleration. This is centripetal acceleration. Okay, not angular acceleration. Angular acceleration, etc., we will learn in the angular motion chapter. Okay, now let's solve 3 numerical questions, which is super duper important. So that will give you an idea what type of questions might come. So 3 numerical questions back to back. Cricket ball is thrown at 28 meter per second at 30 degrees above the horizontal. Find the maximum height, time of flight and range. So basically it's a formula based question. Directly you put the formula, get the result. The things that you need to note is here the speed of the ball is 28 meter per second. So it is given in meter per second. In case it is given in kilometer per hour, you needed to convert it into meter per second by multiplying 5 by 18 factor. But here it is not required. You directly can take that velocity is given by 28 meter per second. Angle of projection is given as 30 degrees. Okay, at 30 degree above the horizontal. Remember, this is given in terms of horizontal. If it is given here, if it is vertical is mentioned, you need to change the angle to 90 minus theta. Okay, that is one important point. Remember, all the angles we measure with respect to horizontal only. All the angles we measure with respect to horizontal only. That is the one condition. Okay, so v is equal to 28 meter per second, theta is equal to 30 degrees. Now what? Now let us find the maximum height. So maximum height is given by v square sine square theta by 2g. Only we need to put the formulas and calculate. That's it. Nothing, no rocket science over here. So v 28 square sine square theta is sine 30 whole square. So sine 30 whole square. Now here one thing is that the velocity is the g is given 9.8, so you need to use 9.8 and simplify. I think it will be, you can cancel it, but you need to use a little bit of calculator perhaps. So try to calculate whatever the value of height, that will be the value of height. Okay, I'm not doing the calculation here, calculation part. Obviously you can do it using a calculator. If you want, I can do it here as well, but let's keep something for your homework. So this is the height. What about the time of flight? Time of flight is 2, twice of the maximum height. So that is 2v sine theta upon g. Okay, this is the time of flight. Put the values and solve it. 2 into 28 into sine 30. Sine 30 is half, by the way, if you wonder, divided by 9.8. Okay, I think it can be cancelled. 9.8, 4.9, you might cancel it. Yes, 7 by 7 you can cancel it, and you will get some value again in this case as well. Again, this is a homework part. Try to solve it. What is the time? And remember, here we are calculating the height, so the final answer will be given in meters. Okay, that is super duper important whenever you are solving a numerical question. Remember, without units you will lose marks. So no matter what question you are solving, always find out the correct unit for those questions. Okay, here it will be again, you will calculate and get some value that will be in seconds. Okay, that will be in seconds. Time, right? Time is in second. And last is range. What is range? Range is given by v square sine 2 theta by g. So remembering these equations, these values are super duper important. That's why you need to practice a few of these kind of questions as well as the derivation of these equations. So once you have done these derivations, once you have solved few numericals, these values will be etched in your head. This is not going to be end over here. In the KCET exam also there will be question based on these concepts. So you need to remember these equations. These are super duper important. You cannot skip these equations. They are very important. Okay, not just very. Yes. Now again, v square is 28 whole square sine 60. Why 60? Because sine 30 2 theta becomes sine 60. So that is one important point again to remember that. So that for calculating range, the value changes slightly. Divided by g, g is 9.8. Again simplify and tell me the answer in the comment section below. So in the comment section below, calculate h, t and r and mention their values in the comment below. I will see if you have solved it properly or not. Now let's move on with the next question. The resultant of two forces acting at an angle of 120 degrees is at right angle to the smaller force. If the greater force is 8 Newton, find the smaller force and the resultant. So very important and interesting question is here. So basically here we have two vectors. Suppose this is my vector A, okay, and there we have another vector. Okay, this is my smaller vector, say vector A. This is my bigger vector, say vector B. Okay, the angle between them is given as 120 degrees. Right? Now it is mentioned that the resultant of these two vectors is at 90 degrees with the smaller vector. So it is at an angle 90 degree with the smaller vector. What does that mean? That means this angle is 90 degrees. Right? So and they are asking you, this is given as 8, unit is given as 8. What is this value? What is this value? Okay, so resultant can be calculated if you can find A, but obviously A is not given here, so you have to find A and then only you can calculate. Now remember that this angle is the angle made by the resultant. We know that angle made by the resultant tan phi is given by what? The other side, this side. Okay, you are calculating the angle with respect to this side, right? So that means you have to go here, that is B sine 120 divided by A plus B cos 120. Okay, so this is the angle phi. Now here it is mentioned that phi equals to 90 degrees. Now what is the value of tan 90? Tan 90? Tan 90 is infinity, right? So tan 90 is infinity means what? So only thing that you need to consider, because it's a tan 90, okay, this is a very special case, the denominator must be 0. Okay, so tan 90, because phi is 90, that means therefore you don't need to put the value of tan theta and compare it, because it is only tan 90. You don't need to worry, you just need to write A plus B cos 120 equals to 0, because anything divided by 0 is infinite. So tan 90 is basically, if you are writing tan theta equals to say x by y and theta is 90 degrees, that means y must be 0. That is the one and only condition for tan 90. So the denominator must be 0. So now we will put the value of b, we will put the value of cos 120 and try to simplify it. Okay. So A equals to minus b cos 120. Now cos 120 can be calculated in two ways. What I like to solve is this method. Okay, always use 180. Okay, here it is 180 minus theta. Okay, 180 plus theta, 180 minus theta. So based on this case, we always use this method. Okay, this gives you the same cos value. And which quadrant it is, I hope that you are aware of 4 quadrant. Okay, so this is the xy plane. Okay, so this is x, this is y. Okay, this is minus x, this is minus y, right? Any angle coming over here, this is called first quadrant. This is called first. Okay, next it is second, this is third, and this is fourth. These are the fourth quadrant. 4 quadrant. Quadrant means 1/4. Quad means 4. Okay, quadrant means 1/4. Okay, so here you have to remember one very simple thing: all sine, tan, cos. Okay, so all the angles that you measure, okay, the standard table has 0, 30, 45, 60 and 90. That is the standard table. Okay, along with that I like to add 2 more angles, 37 and 53. But in every case, if the angle is more than 90, then it starts creating confusion. So you have to remember that any angle which is greater than 90, so this is your 0 degree, up to this is 90 degrees, it is 90 to 180 degrees, okay, 180 to 270, 270 to 360. This is how the angle goes, right? Now everything, all the angles, if it is less than 90 up to 90, every angle value is positive. Sine, cos, tan, cosec, sec, tan, cot, all the values are positive. Okay, that's why first quadrant all angles are positive. In second quadrant, only sine is positive. So sine 120 is positive, sine 150 is positive. Okay, cos 120, cos 160 are not positive. That is a super important point that you need to remember. Okay, so second quadrant, only sine and cosec, opposite of sine, cosec, only sine and cosec are positive. Okay, in the third quadrant, tan and cot are positive. In the fourth quadrant, cos and sec are positive. Okay, in physics, most cases first and second quadrant comes into picture. Most cases, 99.9999, very rarely third and fourth quadrant comes into picture. Okay, anyway, so as you can see, sine is positive, but here what we have cos 120. Cos 120 is a angle which falls in the second quadrant. So in second quadrant, cos value must be negative. So when you are doing this method, it gives you minus b minus cos 60 degrees. So this 180 minus, remember one very important point. Okay, cos of 2 pi, okay, or pi minus theta equals to minus cos theta. Okay, cos of pi minus theta is equals to minus cos theta. Okay, that is an important point to remember, right? So here it is complementary angle, right? So here it is minus cos 60. So minus minus plus, you get b. The value of b in the question is given as 8 Newton. So this one is given as 8. So let's put that value. So minus minus plus 8 cos 60. What is the value of cos 60? Cos 60 is half. Cos 60 is half. Okay, you need to multiply it. It is not 8 and half, it will be 8 into half. So the value of A is 4 Newton. So value of A is 4 Newton. So A is calculated, B is known. So what will be the resultant value? You can use one of the very simple formula, which is R equals to square root of A square plus B square plus 2AB cos theta. Okay, now if you see here, cos theta comes out to be minus half. So we will use that knowledge. That will save us some time. You don't need to write cos 120 and then again convert it into minus 60. No, not required. A square means 4 square plus b is 8 square plus 2 into 4 into 8 into minus half. Okay, cos theta here is cos 120 degrees. So cos 120 is minus half. Okay, because it's a minus cos 60. Okay, so if you find that out once, you don't need to do it once again. So 2 cancels, minus sign obviously will be there. So 4 4s are 16 plus 64 minus 32. 4 8s are 32. Right, so it will be 16, 70, 80 minus 32. 80 minus 32 is 48. It will be 48, which is very close to 7. Okay, if it is 49, it will be 7. It will be 6.99. Okay, which is very close to 7. Okay, now in your first PUC final exam, you are allowed to use calculator, so you can use calculator to calculate the exact value, but no one will deduct marks if you write 7 Newton as well. Okay, interesting question, super duper important question for your final exam. Okay, remember, this is a teacher's favorite question. Now next, another question from your projectile motion. A football player kicks a ball at an angle 30 degree to the horizontal with an initial speed of 20 meter per second. Calculate maximum height, horizontal range reached by the ball. Here the difference is the g is given in 10 meter per second square. So that calculations will be slightly easier. Again, same question. Angle here is given 30 degrees. Okay, the speed is given 20 meter per second. First step we need to calculate is the maximum height. So maximum height is what? V sine 2 theta by V square sine 2 theta by G? No, V square sine square theta by 2G. Don't confuse between formulas. Do not confuse between formulas. Okay, V square will always be there. Okay, now 20 square into sine square theta. So this one I will do the calculation because I want to show you how to solve quickly without calculator. Sine square theta, sine 30. So theta is 30 degrees. So sine 30 is half and cos 30 is root 3 by 2. Even though cos 30 is not required, but just writing for reference. And sine 60, it will come in handy. Sine 60 is root 3 by 2. Okay, now let's see. V sine square theta means half whole square divided by 2 into 10. Now let's simplify. Okay, it will be 20 into 20 into half into half divided by 2 into 10. 0 0 cancels. Okay, this 2 cancels, this 2 cancels. We got 10 by 2, that is 5 meter. Maximum height, it will be 5 meter. So maximum height reached by the ball is 5 meter. Now let us calculate the horizontal range. Horizontal range is given by V square sine square theta, right? No, V square sine 2 theta by G. V square sine 2 theta by G. You have to practice these things, then only you will be able to memorize it. V square is given by 20 into 20. Instead of writing V square, I am directly writing 20 into 20. That saves time. Sine 2 theta is root 3 by 2 and divided by 10. So 10 cancels, 2 cancels. We get 20 root 3. 20 root 3 meter. Horizontal range is also in meters. Okay, this will be the answer for these two these question. Okay, now if you are interested, root 3 is given by 1.774. okay, so it will come out to be approximately 35 meter. Approximately 35 meter. Obviously, if in KCET, both options can be tested. Okay, 20 root 3 or 35 meter, because they know, they want to check whether you know the value of root 3, the closest value of root 3, root 3, root 2, those values you need to remember. Okay, root 3, root 2, at least these two roots, value of pi, these are the expected values that you should remember and apply that in the exam as well. Okay, so this is the 3 questions that I have solved. Now let us look into the chapter summary once more. So first is scalar versus vector. Scalars are only magnitude, vectors have magnitude plus direction, obey the triangle law, obey the parallelogram law for addition. Okay, resultant of magnitude, so resultant of 2 vector is given by square root of a square plus b square plus 2ab cos theta. Okay, the law of cosines. Okay, components, so when you are dividing a vector into components, okay, it comes out to be rx equals to so Rx is basically the resultant's x component of the resultant. X component of the resultant is the addition of the x component of the 2 vectors. Okay, so if you have 2 vectors, say vector A and vector B, okay, if you take the x and y component of A and B and add them, you get the resultant's x component, and if you take the y component of these two and add them, you get y component of the resultant. Okay, this easiest way to add vectors. This is the easiest way to add vectors, but as you know that not always this kind of method will be applicable. For example, the solve problem that we have solved, there was no xy component given in that case, so you cannot solve it. So but if xy component is given, this is the easiest method to add 2 vectors. Okay, independence. Now in 2D motion, okay, 2 independent 1D motions along the perpendicular axis can be considered. That is the resolution of vector. So for example, when you throw a projectile, the projectile can be considered having a vertical motion, having a horizontal motion, right? Vertical motion and horizontal motions are 2 independent motions. Okay, so whenever the object is moving in the horizontal direction, okay, you can treat it as separate motion. The particle which is moving in the vertical direction, sorry, just getting confused, vertical direction, the vertical motion can be considered independent as well. The only common link between these 2 motion is the time, because time has to be same for vertical motion and the horizontal motion. They are not having at 2 different times. Only the common link is time. Other than that, they are independent of each other. Okay, in case of projectile, parabolic path, okay, you can calculate ignore this equation I have solved, written it multiple times. They have tried to write it. Now one important point I forgot is that the range is maximum. I will come to that in a while. Okay, circular motion acceleration is given by v square by r and omega square r always. Okay, always directed towards the center. Circular motion, centripetal acceleration, always directed towards the center. Now one important point that I forgot to mention, let me go back there where I was discussing about this. Okay, this one, right? Yes, so range is maximum at what angle of projection? If velocity remains, the value of velocity remains same, there is a particular angle of projection where the range becomes maximum. Okay, so where do you think this range becomes maximum? So the range will become maximum. So range is given by this formula. Now v square, I am saying this is a fixed value. Gravitational constant is constant by nature. So what is this value of 2 theta? So we can control the angle theta to get the range maximum. So if this sine 2 theta becomes maximum, then we get the range maximum. Okay, if sine 2 theta is maximum, we get the maximum range. Right, now what is the maximum value of sin theta? Maximum possible value of sin theta is 1. Sin theta's maximum value is 1 and minimum value is minus 1. Remember this, sin theta has a maximum value plus 1, minimum value minus 1. Okay, so from here we can say that sin 2 theta equals to sin 90 degrees, right? Maximum value of sin is 90 degrees, so sin 2 theta equals to sin 90 degrees, or from here we can write theta is equal to 45 degrees. So range is maximum when theta is 45 degrees. So if you project a projectile at an angle theta equals to 45 degrees, you get the maximum range. That is very important. It is not for maximum height, by the way. This is for maximum range. Range is maximum when theta is 45 degrees. This is a very common question for MCQs. Okay, another tricky question. Okay, when the height will be maximum? Height maximum for what theta? So this is a homework question. Try to figure it out and answer me in the comment section below. Okay, height maximum for what angle? Okay, now this is the end of today's session. I guess nothing is there. Yes, so this is the end of today's session. If you have any other questions, any other queries, do feel free to ask me in the chat section below. As well as if you have not yet subscribed to our channel, don't forget to subscribe. I will be back with more sessions very soon. Till then, bye. See you in future lecture. Tata.